and exocrine. Because what we're going to see for the exocrine function, the digestive juices that will get secreted or released. The endocrine portion. Your textbook gets very detailed. I'm going to try to keep it at a level that's not quite as detailed as the textbook, but when we look at the structure of the pancreas, embedded into the cells that are making the gastric juices, looks like what are islands. That's what is meant by islet. Islet simply means an island. So embedded throughout the pancreas are these little islets, these little islands. Those islands contain an alpha cell, a beta cell, and a delta cell. And they usually represent them with the Greek letters. I just didn't do it in my PowerPoint. But these cells right here, these cells, okay, the islets of Langerhans, their job, secrete the hormones to regulate glycemia. Ever see all the information about, oh, well, this affects the glycemic index in this way and that way and that way? What they're telling you is it's affecting the blood glucose concentration. We've got alpha, we got beta, we got the delta. Their job, respond to nutrient levels. So we eat, and the body needs to determine what is it that we need for digestion of those nutrients. Then, how is the body going to utilize those nutrients? The alpha cells, they secrete glucagon. But note, this is between meals. Do you guys remember chapter 26 in part 1, where it talked about the digestive system and how there are gut-brain peptides, and they're going to be controlling our hunger sensations, when we might be full, the gastric emptying, that sort of thing. Do you guys remember that from part 1? A little bit? Okay. Well, if you remember, when we eat a meal, like for example, how many of y'all had breakfast this morning? Breakfast is the most important meal of the day. And start that day off as soon as your feet hit the floor, drinking a glass of water. Just say it. Breakfast is the most important meal of the day. So, those of us who ate breakfast, all right, we're kind of now in between our meals. Those who ate breakfast, y'all planning to eat lunch? Yeah. Me too. Okay? Because I was raised on, you had breakfast, you had lunch, you had supper. All right, that was our structure growing up. So that's pretty much what I carry now into my adulthood. Now, if my blood glucose drops between my breakfast and my lunch, let's say, for example, that I'm on a diet. Yeah, right, okay. Now, that means maybe my breakfast was more protein-based. Therefore, the glucose wasn't as much. So, whatever the body had at the time of eating before my next meal, there's not enough in the blood. So basically, those isolates, those islands, the alphas will secrete glucagon. Glucagon will go to the liver and promote glycogenolysis. Let's take that term apart. Glyco meaning a glucose molecule. Well, actually, let's put the glycogen, because remember, when you eat glucose, you don't use it immediately. It's stored in the form of glycogen in the liver and the skeletal muscle. What does it mean to lyse? To break apart. So it would basically go to the liver where glycogen is stored and lyse the glycogen, and I got a glucose. And then that would release it into the blood and raise my glucose levels. Then good deal, I'll eat my lunch and we'll start all over. Take a break, be back at 9:30.